All right, welcome back to Thursdays with me. I'm Ron. Today is March St. Patrick's Day, so I tried to figure out how to turn the background green, but I'm actually not technically literate enough to do that, so I couldn't do it. All right, but happy St. Patrick's Day if you do that sort of thing. We got some more inequalities for you today. We got a few left from last time. We only got to go through a couple of those last time. And then some more good stuff for you. So let's do some of those. Again, here's the copyright attribution. Once more, just for the sake of the recording, we can use the freeware problems. Anything that's from the free GMAT prep software we can use. Anything that's from a paid GMAT source we can't. It's pretty easy to differentiate those. If it ends with PAC, we can't use it. If it doesn't from them, we can. That's pretty much how it works. Okay, let's do a problem. Let's do one. Let's do it. How about this one? This one is actually not from GMAT prep. This one is from ours. By the way, we do assume a certain level of we assume a certain level of basic literacy and data sufficiency. So we assume that you know the data sufficiency answer choices here. So if you we assume you know what A, B, C, D, and E are. That's where you indicate the multiple choice answers to this. This one is from our tests. In fact, I wrote this problem. Okay, go for it. Okay. So, very interesting. Well, so I don't normally put the answer distribution on the board, but I'm going to this time because it is interesting. It's interesting for a couple of reasons. It's interesting because, first of all, there's this massive favorite, which is actually wrong. This is not the right answer. So nope. Even though it's the answer that is by far the favorite of the crowd, but it's not correct. But what's more interesting to me is that so many people pick choices B and D, boy and dog. I mean, there's a total of, maybe those are just random guesses, but there's a total of 7 people who picked these choices. Where, that means that 7 people said that statement 2 was sufficient. Which is a bit crazy if you think about it, because statement 2 just tells you that about C and A, but it doesn't tell you anything about B. So just make sure that you back up a step from this for a second. So remember, this is a yes/no style of problem here, and we'll word about inequalities here in a bit and what kind of stuff you should be thinking about when you do think about this. But absolutely nobody should have an answer box. What is an answer box? You should have the same answer. This is where you pick multiple choice answers. Same place as everybody else does. For this graphic that we put on the screen. This is where you pick multiple choice answers. underneath you find your name in the thingy, and then underneath your name there's this letter A looking thing, and then you see a pull down menu. So you'll see that on there. Okay. So, but yeah, I mean, there should definitely be nobody picking B or D here, because, I mean, statement 2 is pretty clearly not sufficient here, right? Because you remember how this works, right? This is a yes or no style question. So a yes to this question would mean that A and B and C are in that order. So it means that A is less than B, which in turn is less than C. And then a no to this question means that anything else. So sufficient means that only one of those can happen, and then not sufficient means you can make both of these true. So it's just the same old deal with making those happen. So we've talked about this kind of device in other study hall sessions. So let's just make this organizational device that we've talked about before. So can you make A less than B less than C, or can you make anything else happen? And then for statement 1, for statement 2, and possibly for both. And then this is your goals in front of your face, and if you have this organizational device on your work, then it'll help you keep everything straight, what it is that you're trying to do. So the deal is, if you check off both of those boxes, basically in a column, then not sufficient, right? And I mean, this sort of device is something that I introduced in there's a bunch of study hall sessions on yes/no data sufficiency questions. You can check those out if you want. But if you check off both boxes in a column, then not sufficient for that statement or combination of statements. So where this column is for statement 1, this column is for statement 2, and this column is for both if you get to that point. Okay, coming into statement 2, guys, I mean, if all we know is that A is less than C, then it's definitely possible for B to be in the middle of those. But it's also possible for B to not be in the middle of those, right? So statement 2 not sufficient. Smiley face if that makes sense about statement 2. So I mean, again, people picking B boy, D dog, I mean, I'm kind of curious as to what the deal was there. But this just means that A is less than C, and that's all it means. So we have total freedom as far as B goes, which means that both of those things are possible. So we could have that, but we also could have that A less than C. We could have other situations too. We could also have B less than A, or B could be bigger than those, or we could even have equal. We could have, I mean, B could equal A, or it could equal C. There's just so many possibilities, right? So there's just loads and loads of things that could happen. So both of these are possible. This is not sufficient, and that should be pretty much an instant disqualifier. Okay. As far as statement one is concerned, I mean, let's talk about statement one. Yeah, let's talk about it. So inequalities are not equations. You probably knew that, right? There's your fact of the day. Fun fact of the day. Inequalities are not equations. I mean, how not? What are the two ways in which they aren't? So there's, first of all, there's this whole idea of a range of solutions, okay, that thing. That thing about fractions, I don't know, that has to do with inequalities, though. That range of solutions, so therefore this whole idea of minimum and maximum might matter, okay. In a way that they don't matter in equations, sure. But also, here's the other thing, right? I mean, you probably remember in some sort of junior high math sort of thing, if you were solving an inequality like this, negative 2x plus 3 is less than or equal to 5. Okay. Well, the first step of that would just be normal subtraction, right? And then everything would be normal, and that would just be negative 2x is less than or equal to 2. But then the next step is not that normal. What else? Like, what happens when you try to do this division step? Okay, so you have to like deal with turning signs around in a way that you don't. Because with equations, so like the deal with equations is, like intuitively it's not that hard to understand why you have to do that step. I mean, you know, like this is really this has to do with this other thing that we're talking about here. Signs matter is basically the point of this. So signs matter. So you have to think about signs. Consider them, at least, in a way, more so than with equations. I mean, it's easy enough to understand why, like, this is from an intuitive standpoint. I mean, when you divide, when you divide by -2, you can just think of that intuitively as two steps. You can think of it as cutting something in half and then just reversing a sign. And when you reverse a sign, it should make sense why you would flip inequalities. Like, if something is more than, like, 5, then you can intuitively understand why minus that thing would be less than -5. So it makes no sense. But the deal is, like, when you think about stuff like this, you really have to watch it with, I mean, the minimum and maximum here are not so much going to be issues, but you need to be very careful with signs here. So careful with that, right? So like with statement 1, let's test cases for that. I mean, like, the first thing you're probably going to think of for statement 1 is probably going to be pretty straightforward type of cases where everything is positive. So for statement 1, yeah, like let's say A, B, C. So you might pick C, B, and A in that order. So that, and then check that 1 over C, 1 over B, 1 over A, and then A, B, C. Okay, so let's make some columns for that. The first thing you might think of here would be something like, I don't know, 1, 2, and 3. Because then this would be 1/3, 1/2, and 1/1. And then this works the way that you want it to. I mean, you have to check this statement to make sure that it works, and it does. And then, indeed, it is true that 3, 2, 1, that's 1, A is 3. I have this backwards, don't I? I do. I have 3. Okay, let me just do this. This is the other one. Okay, so in this case, this is 1, 2, and 3. So 1, 2, 3, and it is true that 1 is less than 2, which is less than 3. So that's going to check off this box. Now here's the deal. Like, what is our only goal in life at this point? And this is where it helps to make this device on your paper just to remind yourself. But what are we trying to do at this point? Don't say things like prove it wrong, because that's not a thing. Trying to find, like, make this as concrete as you can. Trying to, imagine that you are actually trying to make Excel do this. Like, trying to tell Excel what you want it to find. Excel doesn't know what words like wrong and counterexample mean. So you see, part of the problem here is that people don't know what the goal is in the first place, right? You want, I mean, you should literally, like, imagine that these are actually columns in Excel, and you are actually programming Excel to decide whether things were sufficient or not. Because you could do that. You could actually program Excel to test these cases. And I mean, Excel doesn't know what wrong means, and Excel doesn't know what not true or counterexample or doesn't work means. I mean, Excel does not know what any of these words mean. So you need goals that Excel understands, right? You want B to not be between A and C is what you want. You want those to not be in that order. Or you want this order to be anything other than this, while still maintaining this order, is the point. So, and one way that we can really do that without too much fuss is to just mess around with signs. I mean, we can just make C negative, or we can just keep B and A where they're at. You know, we can just keep those at 2 and 1. So 1 over B and 1 over A can just stay where they are. And then if we just make C something negative, like, I don't know, negative, yeah, people are using negative, let's use like -10. Then it doesn't, yeah, as long as anything negative, it doesn't really matter, but that's going to throw it off balance, right? So this works. I mean, negative anything is still less than positive anything, so that still satisfies statement 1. But now this is absolutely no longer true, so we can check off this box. Well, looky at that. So this is not sufficient. You put commas. Oh, okay, I see what you mean. Now this is a product. So what they're trying to do with this is just telling you that none of them are 0. Although that is, even if this were, this is actually the same thing as that. That doesn't matter. This is the same as A, comma, B, comma, C are not equal to 0. Because that's, even if you put commas in there, it doesn't matter. Because they can still be negative. So ironically, that doesn't matter. If they told you positive, that would be a whole world of difference, because positive products is very different from telling you that individual numbers are positive. But ironically, that's a mistake that doesn't matter, because telling you their product is non-zero is in fact exactly the same thing as telling you that all of the individual numbers are not zero. So, okay, but notice this is not a stretch. This is not obscure craziness. I mean, the two kinds of things that you think of as things when you think of inequalities should be extremes and signs. So, meaning it's not nutso that you should think of something like that. It's not crazy at all. This should be the first kind of exception that comes to mind. So any questions about individual statements? Okay. Now, here's the deal with this. If you have the statements together, we got to combine these things. If we put them together, if we just consider this, I mean, let's take our eyes off of B for a second. I mean, if you just consider for a second just C and A. Consider the fact that 1 over C is less than 1 over A, and C is greater than A. For a second, this is how numbers behave when they, I mean, if they have different signs, these would be opposite. All right, can you guys hear me now? What was the last thing that you heard me say? Okay, so you mostly heard everything. That's good. Say. These things have the same sign, right? Like because if they had opposite signs, then if C were negative and A were positive, then 1 over C and C would both be less than 1 over A and A. So if you have this kind of behavior, then this means they have to either both be positive or both be negative. So what this means is that you can't have this kind of thing anymore. So then if you have these two together, then you've got the same sign. And so then within the same sign, reciprocals, which means, 1 over the number, within any particular sign, whether it's positive or negative, reciprocals, which means 1 over the number, get smaller as numbers get bigger. So what that means is, since we know they're the same sign, so if we know same sign, then 1 over C less than 1 over B less than 1 over A definitely means A less than B less than C. So that's sufficient. Don't they have to tell you what? No, we figured it out because we know it from the two statements together. I mean, we know it because we know this and we know this from having that. That's the point. If we have the two statements combined, then we can figure that out. We can put this information together and we can figure it out. Otherwise, oh, of course, otherwise they're going to tell you that. And that's the point. And I mean, you should be tuned in to thinking about signs because this is an inequality problem, and signs are a huge, big thing on inequality problems. You should definitely have that at the forefront of your mind. But the whole point of having these together is that you should think about that. The other thing about statement 2 also is that they're telling you this, which, considering that statement 2 is part of this, that should make you think about, like, why are they doing that? It should very strongly make you suspect that this is necessary, because it's considering that this is a piece of what's already the goal statement, that should make you look at that as very interesting that they would do something like that. It's probably not for no reason that they would do that. Okay. It is a piece of statement 1, which should make you kind of suspect that it's not stupid that it would just be put there like that. Exactly. I mean, yeah, it's probably not totally random. Anyway, all right, any other questions about this problem? Again, the biggest takeaway here is that you should really think about signs, especially before you jump to conclusions about stuff like statement 1. Signs are a thing. They're a very important thing. Okay. Let's do another one. And this one's from GMAT Prep. Yeah, see that cat. This one's from the prep software. Let's do this one. Remember where those multiple choice answers are found. Go for it. Can you guys see the question? Most people can't see the question. Let me try to page back and page forward. See if there's anything. Okay, you should see it now. All right, let's talk about it. We have an almost perfectly bimodal response here. Look at that. Look at all those C's and E's. We have almost perfectly bimodal. There's your word of the day. It's like when you have two peaks. There. Bimodal response distribution. Two favorites. Okay, well, let's discuss this. Talk about it. Do you know what they're doing with this here? Like, is this anything astoundingly deep that you need to pay a ton of attention to? Yeah, no, it's not really. It's what Kevin says. Kevin actually nails it perfectly here. They're just trying to make sure that the denominator is not 0. So that is exactly what it is. I mean, they'll do that. This is important to know because when they give you conditions in the problems that are real conditions, you have to make sure that you are absolutely using every single one of them. But in this case, this is really just bookkeeping, and this is just being administratively thorough, pretty much is what this is. So, but if they give you facts that are real facts, you need to make sure that you are actually using all of them in some sort of way that is genuine. So, okay. Can we multiply through by x plus y right now? Can we do that? Heck no, we can't. Nope. Can't do it. Because signs, we don't know the sign of that. Can't do it. We can't multiply both sides by x plus y because we don't know sine of x plus y. That's the deal. So what this means we're going to have to do is we're just going to have to test cases again. I mean, because there's not really an algebraic way to deal with this. So let's just deal with it. Let's just test cases. So let's just pick an x. Let's pick x's. Let's pick y's. And then let's just do that fraction. X minus y, x plus y, and then fraction. And then, I mean, as far as columns goes, I mean, I make a lot of mistakes with stuff like this, so it's better for me to just make all of these columns and then not have to worry about it one way or the other. So, like, I would make all of those columns with x minus y and x plus y, just easier that way. Smaller chance of a mistake. So there you go. Okay. So let's do the same thing. There, x minus y over x plus y. Okay. Here's some columns. All right, let's do some stuff. So remember when you do testing cases like this, a couple of notes about testing cases. The first thing about it is that the first case that you test can be totally random. And because remember you're trying to make two different things happen, so the first case is going to make one of those things happen regardless, so you don't need to think too hard about that. And then the second thing is just make sure that you just organize. And I mean, even if you don't have the column set up in advance, just set up columns. When you first run a case through the situation, just set up columns according to the steps that you naturally do anyway. So, meaning if you don't naturally tend to set these kinds of columns up well anyway, then what you can do is just the first time you run a case through the process, just observe what it is that you're doing and then just make columns for it. You know, like just imagine that you had to do Excel or something. Like imagine you had to make an Excel sheet and then just make one. It's like having to document anything else. So, okay, and then this is a yes/no question, so we can document it. We should make that device accordingly. So let's do that. So we have make that whole thing, make that thing greater than 1, and then make that thing not greater than 1. And then that is, that's the thing we're trying to make greater than 1 or not greater than 1. Okay. There's a device. We want to set that up for statement 1, statement 2, and very possibly both of the statements. Okay. And remember that you can set this device up before you even look at the rest of the question. You can set this up just based on the question part of this. You don't need the rest of it. You don't need the statements or the rest of the condition. Okay, so let's do it. Someone give me random x and y values. I don't know, like 1 and 2. That works. I mean, 1 minus 2 is -1. 1 plus 2 is 3. -1 divided by 3 is -1/3. I mean, that is definitely less than 1 because it's negative. So that's going to check off this box. And at this point, our goal in life is to check off that box. I mean, how can I do that? Yeah, if you look at this, because if you want this to be greater than 1, then that's like you want this to be bigger than that, which means if I want subtracting something to give me more than adding it, then taking a negative value for y is a good way to do that. So Lynn uses 2 and -1. Let's use those numbers. So that's 2 minus -1 is 3. 2 plus -1 is 1. So that would be +3. 3 is more than 1. That's not sufficient. Okay. Statement 2 says that y is negative. These were for statement 1. Notice we can import this into statement 2 because y is negative. And it also works for both statements if we get there. So we can check off that same box for statement 2. But we need to check off this box. So we need y negative, and we need to try to make this. How do you make, let's see, what does this say? How do you make the row 2 in your chart? Row 2 in my chart. What is row 2 in my chart? Because it's, so that's just the basics of how data efficiency works. Like this is a question whose answer is yes or no. This is the original yes/no question. This is a yes to the original question, the top row of this, and this is a no to the original question. But the point is, I mean, this has been the topic of lots and lots of, this has been a topic of innumerably many of these sessions, but the reason why people find so many of these things hard is that they think in terms of yeses and nos instead of thinking in terms of like numbers and greater and less and stuff like that. Because the words yes and no are not goals, and they're not things that numbers do. They're not you can't pick numbers that say no. And that's where all the difficulty comes from, is that people have goals that are not goals. You know, it's the same thing as when people, it's like when people say I'm going to eat healthy instead of saying I'm going to cut like 50% of my carbs and 10% of my calories, right? I think I did check the wrong box. Yes, thank you. You have goals that are not goals, and so you can't tell if you've met them or not, right? That's the problem. So you want to define goals that are actually concrete. As far as the mic, I kind of am doing the best that I can do with my setup that I've got here. So, Laura, if I apologize if the sound is tough. I'm doing the best I can. All right. Okay, we need to check off this box. We want it to try to be less than or equal to 1. How can we do that? Well, let's just try to switch the magnitude of the numbers. So if we try 1 and -2, then that would be x minus y would be 1 minus -2 is 3, and 1 plus -2 is -3 is -1. And so then that is a negative number, which is most certainly less than 1. So still not sufficient. And in fact, it looks like this works for both statements as well. So without even having to do extra work, we have accidentally proved that it's E, because we can just take both of these and import them. So it's still not sufficient. And so this is E elephant. There you go. All right. The other thing with these, especially when the answer is E, but kind of in general, that this is kind of very deeply unsatisfying at an intellectual level. I mean, it's not pretty. It's not like high school algebra questions where this big mess of stuff collapses into a neat little thing where everybody cancels out and you just have like a pretty little number at the end. Like nothing cancels anything here, and it's just nothing happens at all, really. You know, it's just nothing happens. It happens on a lot of these. It's just how it works. But yep, there you go. But a lot of these things, the point is as much what you cannot do as it is what you can do. So, any questions about this problem? I mean, notice, again, that the point with these things, I mean, I don't think anybody here really has to learn math. I mean, there's no math to learn here. Like, what you have to learn is, first of all, maybe just making associations. Like, in this previous problem, you had to learn to see this and think about signs. Maybe being a little bit more organized with your setups and frameworks and stuff, like making devices like this one to organize your thoughts and framework and stuff, and the same sort of device here. Understanding that having goals that are actually goals, like not thinking yes and no, but thinking in terms of actual things that are things, like these. I mean, you know, too many people would get this problem wrong and think that they had to go study inequalities, which would be exactly pretty much the one thing that you don't have to go study if you get this problem incorrect. So just make sure that you review these with an honest eye to what it is that you actually are having trouble with if you get it wrong, because it's probably not anything to do with inequalities or anything like that. It's probably everything else involved in the problem. Okay, a couple people are typing. Let me see what it is that you are typing. Okay. How do you choose numbers? Well, there's examples on the board here. I mean, you just kind of do what we did here. I mean, these are not crazy choices of numbers. Yeah, these are perfectly ordinary numbers. Yeah, if honestly x positive, y negative, and they're not allowed to be opposites of each other, these are probably the first two cases that I would think to try. Would be 2 and -1 and 1 and -2. I mean, those are probably, in all honesty with you, those are probably the first two pairs I would throw in there. So, but I mean, remember the name of the game here is do stuff and don't not do stuff. I mean, you should just throw numbers in there and see what they do. But they're not going to give you a problem where you have to think of crazy, obscure numbers out of nowhere. Like they're not going to give you they will never give you a problem where you have to think of some stupid, obscure number and just get lucky. I mean, if you need strange numbers, there will be clues that lead you on a very clear path to those numbers. And if not, it'll be a problem like this one where, the first couple of numbers that a reasonable person would guess will actually solve the problem, like they do here. I mean, you just got to do stuff and not do stuff. So that's what you have to do. So, yep, there it is. Well, 2 minutes is the average time, so obviously you do not have to solve every problem in under the average time. I mean, averages are averages, guys. There will be just as many problems over the average time as there will be under the average time. Okay, let's do another one. All right. And by the way, if anybody here is still thinking this weirdness about I have to solve every problem in under 2 minutes, I mean, that's such a weird thing to think. I don't know where you would get that idea from, but please stop thinking that. Please, for the love of everything that's good in this world. Okay, let's do this one. Alrighty, let's pick something pretty soon. There's a lot of non-responders to this. There you got to pick something, guys. We've got another bimodal distribution. It's the word of the day today. bimodal. That. So I don't feel bad about guessing stuff, I guess. All right. Anyways, let's talk about it. And notice, like when you play around with these things, you'll notice that you can rearrange them sometimes, and that sometimes rearranging stuff will yield benefits, and sometimes it won't. Because, like, what you should do, we'll come back to the problem in a second, but when you, as part of your review, among the many other things you should do when you review these problems, you should consider the ways in which equations and inequalities can be rearranged and reinterpreted. So, for example, let's say that you had this, let's say you had these two kinds of things. Let's say you had this, but let's say you had this. You'll make some discoveries that'll surprise you. You could rearrange this too. You could rearrange this too. You could subtract y from both sides. So you can rearrange it to that. And then this one, similarly, you theoretically could rearrange to just x is greater than y. Okay. Now, I don't think you would argue with me too much about this if I said that this is more intuitive and more useful than the other version, right? Like this is, I mean, the meaning of this is obvious. Like smiley face if you would buy that. Like this is less useful to think about. That doesn't mean anything intuitively to me when I see x minus y is positive. I mean, that's just not intuitive to me at all. On the other hand, you see, the thing is you should avoid coming to some sort of super generalized conclusion, because you'll probably find that this is more intuitive than the other version of it. This is more intuitive and more useful than that is. Because, like, when you see adding two numbers to get positive, this should at least tell you something, right? Like, this should tell you that, okay, I mean, that if I have a positive plus a negative, then the positive outweighs the negative. Like, this could be something like positive big and negative small. Or it could be two positives, or it could be positive and 0. Right. But here it's just like, what the heck? I mean, I don't even know what that means. Like, think about, especially if y itself is negative, think about how not intuitive that is. Like, this just means nothing at all from an intuitive standpoint. In fact, if you were given this, if you had any, if you wanted to intuit this, the first thing you would do is transform it into that, is what you would do with it. So, with these, okay, so you would definitely not want to do anything with this, because you wouldn't, like, m greater than negative z. There's just that's not anything that's fun. On the other hand, these other two statements, I mean, we can maybe do something with those, right? Like, what about statement 1? We can rephrase that as how. Which other sheet? This is the sheet. the M height V. And as far as these, I really don't understand why this is a default, but to me this seems like the kind of thing that should be turned off by default. But if you want that to not happen, here's where you find it. You go in Tools and you go to Chat and you just turn off those emoticons. I mean, I have no idea why this is turned on as a default. This makes no sense to me. It seems like the kind of thing that should be turned off by default. But yeah, I didn't write the program. So okay, you can make it into M is greater than, although it is. I don't know why everybody is saying M is less than 3z, which should be M is greater than 3z. Why is everybody saying that? You just add 3c to both sides. Right. You can rewrite as M is greater than 3z. And I mean, we can use either of those. The thing is that we can use both of those as we see fit. I mean, we could use one of them and then go back to using the other one if we want to. And then if we want to, we can also use this as, we can also rewrite this one as 4z is greater than M. So, sure. Okay. All right, so as far as the individual statements are concerned, remember, let's make goals for this. I mean, yes and no to the original question. A yes to the original question is to make that greater than 0. So make M plus Z greater than 0. That's a yes to the original question. A no to the original question is to make it not greater than 0. This is what you should do with yes-no style data sufficiencies in general. You should just make this device. Just keep in mind what we're doing here, right? This is a yes to the original question. This is a no to the original question. And for statement 1, statement 2, and possibly both. In brackets, okay. It's good to get in the habit of setting this up, just because if nothing else, it'll help you get your feet off the ground here. But also, the other advantage of this device is that it's a step. I mean, that sounds kind of dumb, but it is a thing. And like a lot of the time, people's difficulty here is I don't know how to start these problems. And this immediately takes care of I don't know how to start the problem, because it's a way to start the problem. It's a first step. So if your problem is I don't know how to begin, then now you know how to begin. You just draw this device and you start from there. So okay, well, see, statement 1. If you think of it as M is greater than 3z, then do we know anything about the signs of M and Z? We don't, right? Now think about these. Right? I mean, we don't know, like these could be, they could be positive. It could also be negative. Among others. I mean, you could even have M be positive and Z be negative too. But the deal is they could be positives, which means you can check off this box. And they could be negatives, which means you can check off this box. So there you go. You don't even have to pick the specific numbers, because you know that if you added 2 negatives, they would work out this way. And if you added 2 positives, they would work out that way. And same deal if you, in statement 2, you could have positives, you could also have negatives. Exactly the same thing. So statement 2 is going to work out the same way. Because that's just for z is greater than m. Same reasoning as statement 1. And notice there's no point in wasting the time to come up with specific values if you do this. I mean, efficiency is the name of the game here. Like if you know that you could clearly have positive values and you could clearly have negative values, then you don't need to actually spend the time to generate the value. Okay. What about putting these together? There's a bunch of ways that you could do this. Okay. One way you could do it is to put them together, is to add them. So, I mean, if you can, I mean, any sort of algebra that is legitimate algebra, of course you can do. So, now remember the name of the game is do stuff and then don't not do stuff. So let's try to do that. So that's combined. Let's try adding them. So let's try adding them together. When you get that, when you add those, I mean, you certainly can add inequalities. Yes, you can. So the m minus m, those positive m and negative m go away. And then negative 3z and positive 4z gives you z. And then that's greater than 0. Okay, so we know that z is greater than 0. And then what? So, you know, people do this sometimes. It's kind of an interesting thing that people do. Let me try to make an analogy for what you're doing there. What you're doing there is kind of like you have $1 million and your friend has $1,005,005. Therefore, your friend has $5 more than you. Oh, that's only $5 more. That means you don't know if you can afford a dinner. You see the problem, right? The problem is I told you that you have $1 million. You forgot that. Like the problem is that you still know all of the things that you knew before, right? You don't just know this. Like you still also know all of the things that you that you assembled to get there. Like you still know everything that you know on top of that. So you know this, and you also know this, and you also know this. Should those come in handy, right? I mean, you know all of those things because they're all convenient. Let's say. I mean, these don't stop being true. So now we know all three of these things. So we know that z is a positive number from what you proved. But we know, so this last one doesn't help us, but we know that this one, we know that m is positive as well because it's bigger than z. So z is positive, therefore m is also positive because it's bigger than 3z. So there you go. So both m and z are positive. So what that means is that check off that box and the other box is impossible to check off. So this is sufficient. Two statements together are sufficient. C like cat. You can do that, it's a thing. So this is perfectly valid reasoning. The thing is that you just don't, I mean, you just have to remember that you don't forget the information. Like whatever you knew to get somewhere, you still know it, right? So if you, I mean, same thing, right? Like if you have $50 and your friend has $30, if you add those together to get 80, you can't start picking random numbers to add to 80. Like you still have 50 and your friend still has 30. You can't suddenly make you have 40 and your friend have 40, and you can't suddenly make you have 20 and your friend have 60. It's kind of like that. Like if you have information, you don't suddenly not have that information. You just have to remember what you knew and what you didn't know. So that's all. So your reasoning is perfectly valid. You just forgot that you had more information than you this time again. So this is one way of doing it. You can do that. Smiley faces were good there, especially the person who originally asked about this. If you're a GMAT madness person, especially smiley face, if that makes sense. Kind of. What doesn't? What doesn't make sense about that? Well, that if there's anything unclear about that, it might just be maybe you're new to the whole data sufficiency thing, and you just need to get more used to it, perhaps, or something. But I don't know what you. I don't know what you are asking, which kind of touches on the same issue as before. Like when people talk about prove it wrong or I don't know or something, goals that are not clear or whatever. But I mean, if you know Z is positive and you know this, then you know you have two positive numbers, which definitely proves that n plus Z is positive. So the logic there is pretty bright line. So that means that this has a positive. Right. Yeah, if something is greater than something, if something is greater than something else, though, you can definitely add those. Yeah, I mean, if you had two facing the opposite way, then you couldn't add those. But that's kind of common sense. So you don't have to memorize rules for that. Like if I cost something that, if I buy something that costs more than $10, I buy something else that costs more than $20. Then okay, like something costs more than $10 and something else costs more than $20. Okay, like together those really do cost more than $30. I mean that's pretty clearly true. And like same thing with less than and less than. If it's less than $10 and less than $20, okay, it's obviously less than $30. I mean, if it's greater and less, then you can't add those because then it would matter how much greater, how much less, right? I mean, but there's no need to memorize rules for any of that because you can just think about it in the real world. I mean, but with two greater thans, you can definitely add them together. You're right. Although you should think about that when you review the problem as well. I mean, another way that you can do this, though, is you can just think about these two in this form. You can also think about them this way. You can, if you have these together, you can put them into one. If we know these together, then we know that we're used to seeing less than more than greater than. So we know that 3z is less than m, and we know that m is less than 4z. So we can write this as this. We can write it as that. We can write it as 3z less than m, which is less than 4z. So think about what do we know here? Like when does this happen? Like when does that happen? Yeah, it only happens when z is positive, right? Because if z is 0 or negative, this won't happen. So this actually proves that z is a positive number. And then since m is sandwiched between two positive quantities, that would prove m is positive as well. So because 3z and 4z are clearly positive. So yeah, right. Thus m and z are both positive. So you can do it that way too. You can just do that. And then last but not least, show over time here, but I'll just show you something neat and cool. I mean, you would definitely not ever have to do this, but it's kind of cool. This is like fun extra credit. If you multiply this by 5, you get 5m minus 15z is greater than 0. If you multiply this by 4, you get 16z minus 4m is greater than 0. Oh, hey, if we add these, look what happens. That's kind of cool. Minus 15z and 16z, and 5m minus 4m is m. Wow. That's pretty neat. I mean, obviously, you would never have to come up with something like that, but that's just kind of cool. Okay. If it's a general question that I can answer in literally like 10 seconds, then you can try. But because we're already like way over time here. But otherwise, We gotta wrap up the curtains here, but let's see what the question is. You can try to turn it at me. Okay, well, that's it for today. Thank you, Dr. McKnight. All right. Let me try to go and see if I don't actually. Okay, that is definitely not a thing I can answer in 10 seconds. If there was a short answer to that, it would be very rich. Okay, thank you guys. We are way over time. I gotta run. Let's kill it for now. I'll see you guys in a couple of weeks. I think it might be a different time. Might be a couple hours later next week. Might not. Depends. Go ahead and check the web page and see what it says, just to confirm. But otherwise, thank you. See you in a couple of weeks.